In the cosmic theatre where stars live and die, Betelgeuse, an aging red supergiant, tells a story of stellar proportions. Witness its journey from birth to the brink of supernova, shaped by a colossal collision with another star. This story unravels the mysteries of Betelgeuse's dimming and altered density, inviting you to a breathtaking exploration of star life cycles and the powerful impact of cosmic events. Stick around until the end to find out what's become of this ancient star. Stars are born in space's vast cold realms within immense clouds known as molecular clouds, or nebulae. These clouds, rich in hydrogen gas and dust, span light years across and contain masses of over 100,000 times that of our Sun. These clouds collapse under gravity's grip, creating dense regions called protostars. In these protostars, temperatures soar to millions of degrees, igniting nuclear fusion. This fusion, primarily of hydrogen atoms, fuses into helium, releases tremendous energy, causing the protostar to shine brightly as a newborn star. Take our Sun, for example. Approximately 4.6 billion years ago, it formed from such a cloud. Its core reaches temperatures of about 15 million degrees Celsius, enabling the fusion process that has sustained its light for billions of years. On the other hand, Betelgeuse began its life around 10 million years ago. It's a monster of a star, with a mass about 20 times that of our Sun and a radius of nearly 1,000 times larger. This immense size influences its life cycle, leading to a shorter lifespan and a more dramatic end. Burn bigger, burn faster. While stars like our Sun will burn for about 10 billion years, massive stars like Betelgeuse drain their fuel much faster, often in just a few million years. Their paths split dramatically due to their mass, dictating their lifespan and ultimate fate in the cosmic saga. Betelgeuse, a prominent star in the Orion constellation, is a monumental figure in our cosmic neighborhood. As a red supergiant, it's not just large, it's colossal, with a diameter roughly 1,400 times that of our Sun. This means if Betelgeuse were placed at the center of our solar system, it would swallow the orbits of Mercury, Venus, Earth, Mars, and possibly even Jupiter. This star has transitioned from a main sequence star where it primarily burned hydrogen to a phase where it fuses heavier elements. Currently, its core is likely transforming helium into carbon and oxygen through the triple alpha process, a stage characteristic of massive stars. As Betelgeuse burns these heavier elements, it signals the nearing of its end. But how did Betelgeuse attain its colossal size? Just as the Earth and the Moon are thought to have been shaped by a monumental collision, Betelgeuse, too, may owe its current state to a similar stellar encounter. Astronomers speculate that the fusion of two stars in a colossal cosmic collision could have given rise to the enormous supergiant we observe today. This hypothesis parallels the giant impact theory for the Earth-Moon system, highlighting the transformative power of cosmic collisions in shaping celestial bodies. Did you know? Recently, Betelgeuse became the center of astronomical attention. In late 2019, it experienced a dramatic dimming, losing more than half of its brightness. Astronomers speculated wildly, was this the grand finale to its supernova? But this dimming was caused by a colossal outburst, ejecting a cloud of dust that temporarily obscured its light. No great display just yet. Recent astrophysical research has introduced a captivating twist to the story of Betelgeuse. Observations indicate that this red supergiant exhibits an unusually rapid rotation and a chemical composition that deviates from typical expectations for a star of its type and age. Astronomers now theorize that these anomalies may be the aftermath of a colossal stellar collision, a rare and monumental event in a galaxy's life. The hypothesis posits that several million years ago, Betelgeuse encountered a less massive companion star when it expanded into its red giant phase. Betelgeuse likely began to combine material from its smaller companion due to its immense gravitational pull in this cosmic encounter, similar to a gravitational ballet. This process of collection dramatically influenced Betelgeuse's evolution. Betelgeuse's rotation rate increased significantly as it absorbed mass from the companion star. Stars typically conserve angular momentum, meaning as they grow larger, they spin more slowly. However, the mass influx from the companion star added angular momentum to Betelgeuse, causing it to spin unusually high for a star of its size and evolutionary stage. This merger likely led to a mixing of the stellar interiors. This mixing brought fresh hydrogen into Betelgeuse's core, temporarily rejuvenating it and altering its surface composition. Such a scenario could account for the higher-than-expected levels of elements like nitrogen observed in Betelgeuse's outer layers. This theory of a stellar collision provides a compelling explanation for Betelgeuse's current anomalies. It suggests the star we see today is not just a product of standard stellar evolution, but also of a dramatic and violent past event that reshaped its destiny and left it with the unique characteristics that we observe. Did you know that dense stars like Betelgeuse are cosmic forges, where many of the elements we find on Earth are created? In these stellar giants, intense heat and pressure fuse simpler elements into heavier ones, like carbon, oxygen, and even gold. These elements, vital to life and modern technology, are scattered across the universe when stars explode as supernovae, seeding the cosmos with the building blocks of planets, moons, and even us. The celestial clock is ticking for Betelgeuse, a star nearing the final chapter of its stellar life. Betelgeuse is in the twilight of its existence as a massive red supergiant, rapidly consuming its nuclear fuel. It will exhaust its supply of fusible elements in the not-so-distant astronomical future. This depletion will mark the beginning of the end, as Betelgeuse braces for a cataclysmic transformation. When Betelgeuse's core runs out of fuel, it will no longer be able to support the immense weight of the outer layers through nuclear fusion. This lack of support will cause the core to succumb to its own gravity, leading to a dramatic collapse. Astrophysicists predict that within mere seconds, the core's temperature will skyrocket, reaching billions of degrees, igniting a final, furious bout of fusion. This rapid fusion event will rebound in a colossal supernova explosion, an event so bright that it could temporarily outshine all other stars in the Milky Way. The brightness of this supernova will be so intense that it's expected to be visible from Earth even during the day, lasting for weeks, if not months. Such a spectacle has not been witnessed in our galaxy since the invention of the modern telescope. Following the supernova, what remains of Betelgeuse will depend on its mass at the time of the explosion. The star's core might collapse into a dense neutron star, or if massive enough, it could further collapse into a black hole, an object with gravity so strong that not even light can escape its grasp. Should Betelgeuse reach its supernova stage, it would create a dazzling display in our night sky. This stellar explosion has the potential to shine as brightly as a full moon, turning night into day. Yet, despite its immense brightness, our planet's considerable distance from Betelgeuse ensures that this spectacular event would pose no threat to life on Earth. As astronomers and enthusiasts worldwide await Betelgeuse's final performance, this impending event serves as a stark reminder of the dynamic and ever-evolving nature of our universe. Stars like Betelgeuse are far more than mere points of light in the night sky. They are dynamic entities, living out their lives in a grand cosmic dance. The end of Betelgeuse will be a moment in the cosmic story, a fusion of beauty and destruction that encapsulates the life cycle of stars and the ongoing saga of the universe. Our journey through the life of Betelgeuse has taken us from the birth of stars to the violent beauty of cosmic collisions and the awe-inspiring phenomena of supernovae. As we look up at the night sky, we see not just points of light, but stories, each star with its narrative, each constellation with its history. What are your thoughts on giant celestial bodies crashing in the night sky? Do you think the collision theory holds the key to its mysteries? Share your thoughts in the comments, and don't forget to subscribe for more deep dives into the wonders of the cosmos. Let's continue our journey together, exploring the mysteries of the universe.